Hello, welcome to Uncle Solo's problem solving classroom. In this video, we're going to look at some powers of I in multiplication of complex numbers. You remember from the previous video, I squared equals negative 1, I cubed equals negative I, and I to the fourth equals 1. All right, let's see if we can use that to answer some questions. First question is evaluate negative 3 times I to the power 19. Okay, so the strategy here is whenever you see powers of I over 4 is beyond 4, you want to split it to some multiples of 4 and then the rest. So if you remember the laws of exponents, a to the power x times a to the power I is just the sum of the exponents. So I to the power 19 is I to the power 16 and then I to the power 3. Of course, 19 is also equals to what? 17 plus 2 or 15 plus 4. But we want this to be, one of them to be multiple of 4. That's why we chose this to be 16 plus 3. Okay. So now we have negative 3 times I to the power 16 times I cube. Okay. The reason why we do that is we know I to the 4, I to the power 4 equals 1. We want to make use of it. So if you look at it, I to the power 16 is just I to the power 4. Okay. See that? Now we have it in multiples of 4 right now. And then I cube. This is, remember, okay, this I, this is I to the fourth here is 1. Okay, so 1 to the fourth power times I cubed. Okay. I to the fourth is equal to 1, not 4. Don't make a mistake and say this is 4. So this becomes negative 3 times 1 times I cubed. Okay, are we done? Are we done? No, we are not done. Okay, because I cube is what? I cube, we know from the table that I cube equals negative I. And we need to come and substitute negative I in there. So it becomes negative 3 times 1 times negative I. What's your answer? It becomes positive 3I. Okay? All right, so think of I as a variable, but it's a special variable. Okay, don't let it scare you, intimidate you. Okay, can you do this? Okay, do this and then come back and check your answer. So this is going to be negative 5, and we're going to split 94 into some multiples of 4. So it's 92 times I squared. And we always know that this is going to be 1. So negative 1. The one that's raised multiple of 4 is going to be 1. So this 1. And then times I squared. What is I squared from the table? Negative 5 times 1 times negative 1. We know I squared equals negative 1. We come and substitute it here, and then you are done. Your final answer is positive 5. So be careful here. Watch your negative and positive signs. Okay, now next question here we have complex numbers multiplying, and it's equal to a plus bi. What are the values of a and b? Okay, so let's not tackle that yet. Let's go over here and do some linking exercises first. Here, the first one is simplify 4 plus 3i parenthesis times negative 3i plus 5. How are we going to do this? Okay, we're going to FOIL it, just like you do 4 plus 3x, okay, times negative 3x plus 5. Okay, so we're going to FOIL it. Okay, if we FOIL it, we end up with negative 12i plus 20 minus 9i squared plus 15i. Okay. Then we combine like terms, negative 12i plus 15i is 3i, and then we have 20 minus 9i squared. Okay, I squared. So anything above the I itself, we need to just go to the table or just know what the value is. What is I squared? I squared is negative 1. So we come here and always use parentheses, put in the value of I squared, put it right here. Okay. And now let's go and evaluate. It's 3I plus 20, and it becomes negative 9 times negative 1. It becomes positive 9. So be careful. Do not write negative 9. Be careful. And finally, we combine our like terms again. 20 plus 9 is 29. That's our final answer. This expression ends up being 29 plus 3I. Okay, how can we use that to solve this problem? Okay, so you have this problem here, and that's like I've told you, you use Uncle Solo's guide. What is it? Okay, what is the guide? It is look for key terms, right? Key terms and expressions. What do you see? Okay, you see equations, and then what else do you see? You see unknown constants. So there's a left-hand side, right-hand side, and there's some unknown constants on one side. What should that bring to mind? Identical equations. So we need to simplify, okay, the bulky one to look like the simpler one. So we need to make the left-hand side look just like the right-hand side. So let's come here and then we FOIL just like we did. When we FOIL this right here, okay, we end up with this expression right here. And then of course we also have to add that. And then let's go ahead and simplify it. Let's combine like terms. You see this negative 72 and the 8 are like terms. That's equal to negative 64, right? And then 27i minus 3i, it is 24i. I think I left something out here. It's 24i. And then we have to add it to 56i minus 21i squared equals a plus bi. Okay, so what is 24i plus 56i? That gives us what? 80i. So negative 64 plus 80i minus 21i squared equals a plus bi. Are we done? We want to end up with only two terms on the left, just like we have over here. So what is I squared? You have I squared here. I squared equals negative 1. So we need to go and substitute there. Plus 80i minus 21. Always, I say what? Use parentheses when you're substituting the values of your I. So I squared is negative 1. I put it in here. Okay. And then I finally see this value here. This becomes negative 21 times negative 1 becomes plus 21. So I have negative 64 plus 80i plus 21 equals a plus bi. And then finally, what? Combine like terms over here. This becomes what? Negative 43 plus 80i equals a plus bi. Okay? And then finally, what do we do? Identical equations, what do? We compare like terms on the left-hand side and right-hand side, and we see this a equals negative 43. And then we compare the imaginary part, bi equals 80i, and then b equals 80. You're done. Okay? All right. So go ahead and practice. Apply yourself very well. And all things being equal, you shall what? You shall bloom. Okay? For your exercise, take a picture of question number 9 and give it a shot. See you in the next class. Have a great day. Bye-bye.